And welcome back to Simple Data Management. My name's John Johnson, and we're continuing this course from the previous part 1, where we talked about the concepts of simple data management. But in this part, we're going to go through the actual practices. So follow along. We only got 20 slides, not 30, but most of it's going to be jumping between this slide deck and an example using Rocketfish and Excel. For those of you who maybe don't have a version of Rocketfish on your computer, please go to secondnaturesoft.com and then click on free course. And at the bottom of this page, you'll see all the materials you need in order to participate and follow along in this training. You'll see the presentation, the data sets we'll be using for our simple example, as well as the Excel template and a place where you can download Rocketfish. Now, let's go ahead and talk about the practices of simple data management. First off, here's a quick overview about the practices. We're going to discuss how do you set up your simple data lake. In this case, we're going to talk about setting it up on your desktop, but this could also be for a shared drive, or it could be for any other system in which you are locating your files, like a wiki. We're also going to be talking about data preparation, how we're going to clean and integrate and transform and extract our data. We know from part 1 that this is the majority of the work. As you can see here, 60% of the work is actually cleaning and organizing data sets. That's mainly what we're doing in data prep. And so we're going to walk through examples of how to do that well. Then we're going to talk about a little bit of analysis and how you can reintegrate results with analysis, and then finally about sharing your data. And we're going to give you some examples of institutes that do this well, and as a result, they have more projects, more collaboration, and more publications. So to get started, I want to make sure that we have the same terminology. Once you've downloaded the raw data sources, you should know that these data files are in what we call comma-separated values format, or CSV. These are essentially just data tables in a text file. The first row is going to be the header row, which you can see here, student, age, height, weight, and gender. We call that the header row, and it's going to define all the variable names. Then all the values in the rows following are going to be your records. So when we talk about raw data, the rows are records and the columns are variables, and where they intersect is a value. It's important to note that a record is intended to be that every piece of information captured, every value for the variables, are related to each other by some kind of unique identifier. In this case, we have a student ID that was measured at the clinical site. So when we process these data tables, we'll then produce a data history or a data recipe. This is going to allow for anyone to reproduce your work in the future. It will capture things like mapping variables whenever you join two data sets together and you're appending records, and we're going to also talk about that in the future as well. Or it's going to show you how you can replace variables in terms of the values within them using a find replace, like changing all the values of male in the gender column to be M to have a standard format. So those types of actions that you're going to take are going to be captured in your data history. Then when we're finished, we're going to have what's called tidy data. And tidy data is similar to raw data, except that it's fully cleaned and every row is now an observation. Now sometimes observations are at the same level of information as records, in the cases where you don't do any summarization of your data sets. However, if you are going to summarize your data sets in order to perform your test, and in this case we are, because we've summarized the information about the BMI, taking the mean for all the students based upon their gender and their HIV positivity, in this case we have a higher level of information that we're going to use for our test. And that's when an observation is going to differ in terms of the level of information from a record. So it's important to understand that sometimes observations are the same level of information as a record, and sometimes they're not. But in tidy data, we're talking about the data at the level of information you plan to test. Lastly, we have the codebook, and the codebook is a list of your variables, their description, as well as the potential values that those variables can contain. So in this case, we have the gender variable, followed by its description as being the student's sex, and then the appropriate values are M for male and F for female. Now that we have shared terminology, let's talk about setting up your data lake. When it comes time to set up your data lake, I'm just going to give you a couple of highlights from this slide I do suggest you come back and read it because of the fact that it offers a lot of information, obviously, with all the density of the words here. But these are essential steps for simplifying your data on your desktop or your shared drive. First off, we're going to talk about how you set up the folders inside of your shared drive or your desktop. One rule that every information management paradigm holds is that you should never have more than 3 folders in any section of your shared drive. In fact, more than 3 folders, and likely what you're doing is you're actually putting information that should be in the name of your file into the folder structure. And what that leads to is a file that no longer is self-described, but also is very difficult to share well because you have to now contextualize the information about that file that could be in its name. So for example, I'm going to have a documents folder that has all of my projects in it for 2017, and then I'm going to have the name of the project. And at that point, any other information about my file should be in its name and its metadata. We also want to make sure that every one of your files is backed up securely, and whether or not you use an external hard drive or you use Google Drive, depending upon the size of your files, you need to have a system in place that works for you. There are many services out there that offer standard backup and will continuously run in the background. Oftentimes within an organization, this is done for you. The last thing I'm going to say about folder structure is that oftentimes to find a folder really efficiently, it serves you to pin that folder either to your quick launch menu or inside of your windows or to the bottom of your screen or on your desktop. Wherever you put your shortcuts, make sure you have a shortcut to your current project. It's going to save you lots of time in the morning. Now, inside of every project folder, you want to make sure you have all the files that you would share with someone so that they could reproduce your research. So that means you need your data management plan and the data design that we talked about from before in part 1. This information is going to let the user know that this is how you set up your files, this is how you secure them, who owns them, etc. We're also going to need to have the Ready Data tool. If you have a workbook that you're using to manage all of your data sets, then you should have that file in this folder as well. But if you don't have that file, that's okay. It's not really an archivable format. So this is more so just about locating everything in one place. In addition, you should always have your most recent raw files, tidy data files, data history, and code book, and they should be in open formats. So CSV, text, XML, as long as it can be parsed and read by a search engine, it's good to go. And then lastly, you're going to have an older versions folder. And this is because, frankly, you don't want all those versions that you create to be cluttering up your top level project folder. You want to put all those older versions into the older versions folder so that your project folder stays nice and clean. So when we talk about file naming, and this is probably the most essential and basic element of setting up a good data lake, we want to make sure that that file name is structured and hierarchical. So an example would be that you would give the name of the program that you're working for or the lab, the project that you're working on, and then the test that you're currently conducting. Then add in the date as well as a version number. Again, this is going to help with making sure you don't have more than 3 folders deep in terms of any structure of your folders on your shared drive or desktop. But it also is going to ensure that your file name is descriptive. And so when you share it, someone knows what this file is for and how it fits into the organization. And in many cases, it can help to have a tracker. So you don't have to track every version, but tracking the file name of your standard files as you're continuing to iterate on them is going to help, especially if you have a large organization with lots of independent researchers. And then lastly, and most importantly, you want to make sure that you save early and save often, but that doesn't necessarily mean that you always have to version up the file that you're working on. So you want to save your data, you want to save your files as you make changes to them every time whenever you make an edit in terms of data or the approach. But it's when you make a significant change to your data or a significant change to your approach that you should version up. And so that's going to be critical to make sure that you have meaningful version numbers and that you're thinking about how you're actually treating your data when you create those version numbers and share them with others. Otherwise, version 20 and version 21 or version 50 and version 51 will have no meaning. So with that, you'll have a great system for managing your files. It'll be easy to find, and when you search for your files, you can sort by name and easily identify which file you are looking for, and then start working on it again. Now let's talk about data preparation. So at this point, we're going to get into our demo. I'm going to first talk to you about what it means to clean your data and the type of methods that are used. We'll do a short visual example, and then we'll do a demo inside of Rocketfish and Excel. To get started, the first thing you do with cleaning is you profile your data. And the goal here is to identify any errors. So there are lots of methods to do that. You can use visualization, you can use statistical analysis, or you can use logical tests. With visualization, the number one approach is to use a table, followed by using a scatter chart. There are many other types of charts and visuals you can use, but those two are probably the most useful for most people's work. Oftentimes, we also see that matrices in the form of heat maps can be very useful for large data sets with highly related data, like genetic data. Statistical analysis is going to help you with identifying any issues in your data, especially when it's very large. So if you summarize your data, you can very quickly identify if you have any inconsistencies in your values, or if you have any outliers. So if you do min and max, you can identify issues there as well. So statistical analysis is great, especially when you're working with large data sets. And then logical tests are important for validating records in terms of whether or not you can trust the data in that record. So a good example would be that if you have students and they're under the age of 10, you wouldn't expect any of them to be 6 feet tall. So a very simple test would be to put together a test to say, okay, any student that is taller than 6 feet cannot be younger than 10 years old. That kind of a logical test is very basic. You can get into much deeper logical tests if you use clinical data and you want to make sure that procedures match up and align and there aren't any issues and it's quality information you're working with. We see a lot of people with electronic health records using logical tests to verify that it is an erroneous data. So once you've identified the errors, and we're talking missing values, incorrect values, inconsistencies in terms of naming conventions, then you want to start cleaning that data. So the simplest thing is just to correct the value. And that's oftentimes what we see people do. But you want to make sure you capture your work as you do so. You can also normalize your data sets. So that would be changing values that are correct but inconsistent into one shared format. You may want to reformat your variables. And in this case, we're talking about changing it from a date to a string or to a number. And then lastly, you may be splitting or merging, classifying, or screening your variables as well. We'll talk about a couple of examples of that. I think the most important element about cleaning is that you always capture what it is that you've done, because in the future someone else is going to have to understand how your raw data became clean, and that can be the difference between reproducing and not reproducing your work. So let's take a look at a really simple example. In the top here we have an example of students 1 through 10, and we have their age and their weight as a small subset of the data we'll be working with. If we sort by weight, we can very quickly identify that we have some students that were measured in terms of kilograms and some students that were measured in terms of pounds for their weight. And what helps us to identify this is the context of the fact that 11-year-old will almost never weigh 46 pounds. So we know that there's an error here, and we want to identify that error before we do any transforming of the weight variable. So what we're going to do is flag, and this is a classification cleaning step, we're going to flag that there was a unit error for these students that had kilograms captured as their weight. Another example would be that if we had a large data set, we may want to take a look at the inconsistencies in terms of how gender was captured in the gender variable. So to analyze that, we'll create a summary, and we'll take a look at the count for every possible value inside the gender variable. And what we find is that while most of the values are captured as M and F, we also have other values like male, female, man, and so we need to normalize that to make sure there are M and Fs all across the board with check marks going down. So in order to really put rubber to the road, let's do an example of this. And we'll start off by doing this in Rocketfish. I'm going to click on my Rocketfish icon, which I've pinned to my quick access bar because I use it all the time. And whenever you load up Rocketfish, it's going to initialize all the data sets that you have across your desktop that you've loaded into Rocketfish in the past. However, to match your experience, I have added no data sets yet. And to get started, I'm going to click on the New Dataset button. So clicking here, I can now navigate to any location where my files are located. In this case, I put the files in the download folder where you'll probably find yours, and I'm gonna do a shift click to highlight all the files I want and click open. I could do them one at a time, but I want to save some time here. So now that the files are in my dataset space, I can sort by name and I can sort by date. So I'm going to go ahead now and double click on Site 1 Clinical, and when it opens up, we'll immediately see the dataset in the center of the view. So the way Rocketfish works is that at all times you see three elements. You see your variable list on the left, which is your codebook. You see your grid in the center, which is your data that you're working on right now, and then your history. So if I click across my data set, you'll see that these views are all linked together. If there's any data that's off the screen, I can double click on it in the codebook to jump to that variable's location in the grid, which is great for working with really wide data sets. So now let's go ahead and do that cleaning step we just identified in our last example. I'm going to sort the weight variable, and then here we can see that we have that same issue where some of these students were measured in terms of kilograms. And to flag those records as having a unit error, I'm going to click on Derive Variable from the action bar, and all of your actions across variables and across your data set can be taken from here. And I'm going to calculate the unit flag. So I'm going to say, okay, unit error is going to be the name of my new variable, and I'm going to use an if formula, if, and I can just hit enter, and I'll type in W, and weight comes up, so I'll hit enter again. If weight is greater than 80, then it's okay, so I'm going to give it a 0, otherwise 1, and that means that there's an error. And as I move over to the right, you can see that the check mark says my statement is good. If I were to delete the end parentheses, you can see the statement is not valid, so it won't produce a new variable on the right. So I'm going to go ahead and put in the parentheses, and now you can see I've got my unit error flag. And this is lining up well, so I'm going to hit Derive Variable. And on the right here, you see that my history has been populated, and you can see exactly what I've done. We added a new variable. Here's the function to test the weight to see if it was an error for being in kilograms, and we've added one variable. And this information will always continue to be captured as you work in Rocketfish. So now let's go ahead and perform that statistical analysis on the gender variable. I'm going to click on Aggregate Records, and immediately Rocketfish is going to attempt to do a grand mean of all of our data sets. If I click on the check mark, that will take away all the variables, and now I can group by gender, and then I can count based on the students. So first, the default is going to be that we have a mean for the values in student, but down here in the left I can change that to be the sum, the count, the variance, standard deviation, max, the geometric mean. So these are options for evaluating our data set. In this case, I just want to take the count, so I'll select count, and we can see now that we have 4 M's in the gender column, we have 1 male, 2 F's, 2 females, and then 1 man. So we're gonna go back and correct these values, but with large data sets, this can be really efficient for identifying inconsistencies. So I'm going to X out, and now my data set goes back to its original form, and I'm just going to go ahead and start editing these values. So I'm going to double click into female, the value female, and I'm going to change it to be F, and then I'm going to select apply to all matching records, and I'll hit enter. And now both of the females in the gender column have been replaced with the value F. And you can see that's captured here. For all values for gender matching female were changed to F. No need to write down, it's all done for you. We can do the same thing now for man. And it's always good practice to say apply to all matching cells. And lastly, for male, we'll turn that to M as well. If you do a single record replacement, it looks a little different, but we still capture the original value and what you changed it to. So now we just cleaned our data set for the gender value, and we flagged the weight as having a unit error. We can now move forward and do our next step in the analysis. But before we do, let's take a look at the Excel workbook that we have and how you can do this in Excel as an alternative. So in this Excel workbook, what I provided you is a structure so that you can keep all of your raw data your intermediate data sets and then your tidy data in one place. I've provided a reference table for many different formulas that will be useful for you as you perform your data preparation. But I'm going to show you how to use these formulas so we can move forward. In terms of data history, I've already made changes to this workbook in order to set it up. It takes a long time to bring data into Excel, so I didn't want to sit and have you watch me copy paste values. But I've already captured how I've changed this workbook so that we've got Site 1 clinical, Site 2 clinical, Site 1 blood, Site 2 blood, all loaded into the workbook and ready to go. We also have a code book here which automatically reads the data set that's placed in the tidy data. So as an example, if I add a new variable here, new variable, and I give it a value of 100, you can see that in the code book we have a I have a little error here. In the code book it should be fixed. So if I go over to the tidy data and I put in the new variable, we'll give it a name, new variable, and we enter in the value 100 and go back to the code book, we see that the new variable is pulled in and it says the word number. So in that way, your tidy data is okay. So if I go over to the tidy data tab, I can add a new variable, and we'll just give it the name new variable, and then I'll give it a value. In this case, I'm going to make it 100, so it's a number. When I come back to the code book, what you'll see is that the new variable has been brought in automatically. It's been read in for you, and its type has been detected as well as being a number. And this will continue to detect any numbers or any text based on the first value in that variable. We can also enter in a description that says this is just an example variable, and then we can say the potential values, which right now are just 100. So in this way, you're able to have a linked data set to guarantee through a little automation that you accurately capture all of your variables and their information for the golden data. That's your data history, the code book, and the tidy data set. Now, let's go ahead and take a look at our working data set. Here you see I've already loaded in a record counter for the first 20 records, and this is just an empty template, and we'll come back to use this in a second. Here I've already preloaded some data from Site 1 and Site 2 blood data sets, and we'll talk about that in a second as well. But you can see the same thing, we have a record counter here. So the white tabs are for your raw data, and we don't want to ever have this data change. So after you copy paste your data into these data sets, and you can see that we have Site 1 clinical, Site 2 clinical, Site 1 blood, and Site 2 blood. I just pasted those in. The first thing you're going to do is you're going to go up to review. So you can see here in my ribbon I click on review and then hit protect sheet. When you hit protect sheet and just hit enter, you don't have to give it a password. Now you can't change the values on your raw data, and that's really important because we don't want any of your values to change when it comes to your raw data set. That is sacred and must remain intact. But you can, however, copy it and then paste it into a working data set, which is how we'll get started. So I've just copied and pasted the data from Site 1 clinical, and to be good about this, I should go ahead and say copy paste Site 1 clinical data into working data set 1. And this is, again, we'll just call it setup for demo. So I'm going to go back to working data set 1, and now we're going to do the same cleaning that we just did in Rocketfish. So here I'm going to add on with filters the ability to filter and sort my data. And the first thing I'm going to do is I'm going to go to weight, and then I'm going to select to ignore the blanks because we have some blanks with the 11 records that weren't shown. And now let's sort. So I'm going to sort from smallest to largest. And here again, you can see that we have these data values for weight for a couple of the records, which clearly are in kilograms. So what we're going to do is add in that same variable that's going to identify where we have a unit error. So say unit error, and then we're going to use an if formula. So equals if, just hit tab to open up the formula. we'll select the cell, the first cell in weight on the same record. We'll say if the weight is greater than 80, then it's okay, give it a 0. Otherwise, it's not okay, give it a 1. And then complete the formula. And now I can copy paste this all the way down. So at this point, because of the fact that the information is stored in the same record for this test, you don't have to worry about sorting, and we can then go ahead and we can sort again, and you'll see that the values shift. So this is all working out. So now I'm going to unfilter, and you can see that all my records still have the appropriate counter with them because we kept them together. So the next step I'm going to do is I'm going to perform the summary that we looked at before. In this case, we're going to summarize the gender variable. So I'm going to select my data set, and I'm going to click Insert in the ribbon, and then I'm going to select the pivot table. And just go ahead and hit OK, and this is going to create a new tab which has now read all that data I just selected. We'll rename this Pivot Working Data Set 1. Simple name. And we select the pivot table. Here on the right, you have now a list of all the variables, and based upon them having a header. And we can now drag the gender variable into the row, and you can see all of our values. And then we can drag in the student variable into the values. Now, the problem with a pivot table is that whenever it can, it's going to assume that you want to do a sum. So to change that to a count, we'll go to the drop-down arrow next to the sum of student. We're going to select value field settings. We're then going to select count instead of sum, hit OK, and now we can see the count of each of the values in the gender variable. So if we had a large data set, this would be much more efficient than trying to scan through with your eyes for sorting. So now we can see we have the issue that we had before, where we have multiple values and we just want to have M and F inside of gender. So coming back to our working data set, I'm going to select all the values under the gender column, and then I'm going to hit Control F, and that's going to bring up my find window. I'm going to select replace, and we're going to say find, and we'll type in the word male and replace with M. We'll hit replace all, and you see it made 3 replacements. And then I'm going to tell it to find all the now here's an issue. I've just created FEM because male was a substring of female. So that happens sometimes. So we're going to have to type in FEM and hit replace all. Oh, but I just made a mistake again because those are actually not supposed to become male. So let's back that out. And now order matters, and that was the point of this example. Make sure that you always start with the longest string that you want to replace. So we're going to type in female, and then we're going to change that to F, replace all. Okay, things look good. Then we're going to replace male. Go ahead and type in male, and where it turns that to M, replace all. Okay, just about clean. We still have the M to deal with. So for the man, so we're going to take man and replace it with M. Okay, now we're done. So we just made all those changes. Now we need to go capture that in the data history. And this is good practice for understanding what you need to do. So we already captured that we copy paste that one clinical. Next thing that we're going to do is we're going to say that we created pivot working data set 1, and this was to test for variables in gender column. We also created new variable unit error, and here we can say that we used a formula to test for, and in this case, unit error in weight column, where weight less than 80 is assigned a 1 for unit error. So sometimes it's better to write it out, because if we just copy paste the formula, all you'd see is cell references. It wouldn't be useful. In other cases, sometimes you can copy paste the formula if that helps. And then finally, we want to say that we replaced female, correct spelling counts, with F in gender column. We replaced male with M in gender column, and replaced man with M in gender column. So despite what they may think, that student is also a male although he thinks he's a man. So we've just completed the same work that we did in Rocketfish, and now we've cleaned it up. Now, I'm not going to keep on doing this data history during this example. I just wanted to show you kind of the work that's involved. You can move quickly if you're comfortable with typing fast, and you can work in batches. I suggest you do work in batches, because always going back and forth and switching tabs, you're going to get lost. But never perform more than 3 to 7 actions without capturing them in your data history. That's how much your working memory can remember, so that's as far as you should go before you start capturing what you've done. All right, we're fully oriented to our workbook. We now understand how Rocketfish works. We can move right through the rest of the data prep actions, no problem. Okay then, switching back, we'll go to the next slide, and we're going to talk about integration as your next primary step in data preparation. So there are 2 types of data integration that every database performs. The first is appending. And with appending, what our goal is to add more records to the same existing variables. And the way we do that is we match the variables between 2 data sets, and then once they're matched, we can then add the records and the values in the appropriate place for those records. So the 2 types of methods that are often used for appending are data harmonization, where you are bringing together 2 data sources, and then you are normalizing the variables between them. When you normalize across data sets, we call that data harmonization. And then another is data updates. So when you have data set updates, oftentimes you're working in time series data, and the goal is to add new values to existing records. So you may not be adding in a new record every time. Sometimes you are, sometimes you're not. In other cases, you may just simply be updating a record. When it comes to joining, we're kind of doing the opposite. What we're going to do is match our records using a key, which is a variable shared between the 2 data sets. And then from that key, we're able to line up our records and then bring in new variables and the appropriate values based on the matched records. So we're going to match records to bring in variables with a join. And so the key mapping is the most important part. You can have a single key or a multi-key join. A single key would be just using a single participant ID or some other ID that is unique to all of your records. A multi-key join is when you have a data set that doesn't have a unique identifier, and then you need to bring in at least 2 keys, or create what we call a combo key to join those data sets. There are different types of joins that you can perform. The first is an inner join. That's where you only take the records that match between both data sets. Then there are outer joins, where you keep all the records of one of the 2 data sets that you're joining together. A left outer join means that you'll keep the records of the data set that you're starting with. A right outer join means that you'll keep the records of the data set that you're joining in and ignore the ones that don't match from the original data set. There are then also full outer joins. That's where you keep all the records, those that match and those that don't. So you end up with a kind of a patchy data set at the end, but it's more complete. And then lastly, you can also use these joins in the negative. So for example, I can do an inner join, but then take out all the matching records between 2 data sets. And this is oftentimes done especially in geospatial analysis, when you want to remove the overlap between 2 areas. So for a quick example of how this works, I've prepared a very simple set of tables, tables 1, 2, and 3. And the first 2 tables are both students with their age and their height. And you can see here we have students 1 through 3 and students 4 through 5, and we have their ages and their height. Now to perform the append, what we would do is we'd line up to make sure that the variables are matching, and then we're able to bring in the values for the new records so that they fill in the variables correctly. So that's a simple append. We've matched variables to add records. Now in the second example, we have table 3, which has the student number for students 1, 4, and 5. But instead of having age and height, it's adding in new variables, weight and sex. So what we're going to do is we're going to use the student number as our matching variable, and then we're going to bring in weight and sex for those students that match. So when we perform this join, you can see that student 1 now has the variable weight and sex brought in, so 100 for their weight and their sex is male. And then student 4, same thing, 150 and M for the weight and sex. And then lastly, student 5 weighs 135 pounds, and is female. So that's a simple left join. And that's the kind of join that you most often will be performing whenever you're enhancing your original data set. We're going to go ahead now and show you how to do this in Rocketfish. If you want to take a look at kind of the concepts of joins, there's this really great, beautiful graphic here in the top right-hand corner. I love it. I always refer to it all the time when talking about joins. You can use this link here and explore this a little bit more yourself. All right, let's switch over to Rocketfish, and we will perform some joins. So, opening up Site 1 Clinical, we can see that we have the data set that we were just working with. Now let's take a look at Site 2 Clinical. So Site 2 Clinical actually has a very similar set of variables, so this should be a very easy match. We have the student, age, height, weight, sex, happiness, parents, their adopted status, and their favorite color, of course. So we want to go ahead and bring these two data sets together. What we're going to do is we're going to start by working with Site 1 Clinical, and I can actually create a duplicate of this, and I'll call this combined site data by clicking on rename, and we'll say combined site data. And now I've given this a new name, and we have our data set, and we're ready to append. So in the action bar, you can see the add records button, which is the up arrow. We'll select that up arrow, and then we will select Site 2 Clinical. Now immediately Rocketfish is going to match all of your variables that have the same name, and that's going to save you a lot of time, especially on very wide data sets. But we see here on the left side where we're configuring this action that we still have two variables in our starting data set that aren't matched, and one in our appending data set. So let's take a look, and we see that, okay, the unit error is something we calculated, so we're not going to match that, but gender should match, and we'll see with what. Okay, so the sex variable and gender variable should match. So we'll go ahead and make that match, and if you see here, we've just filled in the patch in our data set. I'll go ahead and undo that again. So you can see that we have this patch in our data set in the gender column. We'll go ahead and make that match, and now our data set is complete. But take a look at one other piece of information. Over here on the right, the unit error has already been propagated into the next data set as part of this preview. So you don't have to worry about dragging, dropping, copying, and pasting formulas. Rocketfish automatically assumes that for any variable that's unmatched, you want to continue the same calculation for those records. So we'll click on Confirm Variable Mapping, and again our history bar blinks to tell us that it's captured that information. And on the right side, you can see the configuration's been captured for you. So that's going to save you a lot of time, no long typing like we saw in the last example with cleaning, and you can imagine all of the typing you'd have to do to capture this variable mapping. So we've just done the append. Now let's do the join. So in terms of joining, I'm going to show you we have Site 1 blood, which here is students with their blood type, HIV positivity, and Hep C status. And I'm going to go ahead and just add in Site 2 blood. And you can see here they perfectly match. There's no difference in the variable names. So I'll go ahead and hit Confirm Variable Mapping, and you can see here in the history that that's been captured. So I'm going to now use my drop-down menu for my action bar to duplicate this data set, and I'm going to give it a new name of Combined Blood Dataset. So now I want to bring the combined blood data set into the combined site data set, so we can have all four data sets together. And this is going to be really fast. So to join, we're going to click on the Join Datasets button with the left pointing arrow because it's the left join. And then we're going to select the combined blood data set. And immediately, Rocketfish has already matched our first two variables, assuming that they are a key. If there was a different key, you can always select that key from the list on the left here, where you can assign the key in the starting data set, and then the highlighted variables are from your joining data set. But if we didn't want to bring in everything, say we just wanted to bring in one variable, we could select the check mark at the top of this list, and then we can choose which of the variables we want to bring into our data. And this allows you to very easily join large data sets where you only want a key value. Happens all the time whenever you're working with genetic data. So let's go ahead now and bring in everything. And once we have the selection that works for us, hit Confirm Join. And again, the history bar blinks to say, I've already done the work for you. Here you go. You joined Site 1 blood, and you have the two linking data set here with the student key. And these are the variables you brought in: blood type, HIV positivity, and Hep C status. So we just combined our data sets. That's 4 data sets in one in just a few seconds. Now let's go ahead and do that same thing in Excel. So moving over to Excel, I'm going to show you how to do this very easily in Excel in a way that's going to eliminate a lot of errors that happen. So what we're going to do is we're going to go to Site 2 Clinical. We're going to make sure that we have protected our sheet. All right, it's protected. We're going to copy, and then we're going to paste, and we're going to paste the variable names and the variable values here underneath our working data set. So by pasting in the header row, we can do a nice trick, which is matching up the variables directly by having the variable names pasted in along with the record values. So we can look here and we can see that all the matches look good. Here's another trick. Go to View and then select Freeze Panes, Freeze Top Row. And so what we just did was we froze the very first row in Excel, and now we can actually show a perfect match between all these variables. And we can see right here we've got the gender variable and sex variable matched up already because they have the same order. So that's a really easy way to ensure that you perform a correct mapping. Once you're done, go ahead and highlight that variable row and then hit right click and delete and select Shift Cells up, not to the left, and then your records will move into place appropriately. Now the final step for combining these data sets is that we're going to take the formula in the unit error, and we're going to copy and paste that all the way down so that we are also testing the second data set. So that was combining Site 1 and Site 2 clinical data sets with an append action. Not too bad. The next thing we're going to do is we're going to combine Site 1 blood and Site 2 blood. So that's already been done, but we want to now combine that data to our combined clinical data set. So if we want to, we can go ahead and actually rename this Combined Clinical Data. And we're going to use a very important step, which is we're going to come into the working data set here, and we're going to copy over the variables. And the reason why we're going to do this, I'll show you in a second. So bring over the variables first to ensure alignment. And now what we're going to do is use a VLOOKUP formula. So type in VL and then tab, that will give you VLOOKUP. And then we're going to select the student age as our key and put a $ before the B so that we lock in the position. We want to always be using that student variable. And then we're going to select our working data set 2 as the data set that we're going to be looking up. Now you have to start with your linking variable. Any variables you want to bring in have to be to the right on a VLOOKUP formula. I know that's a little bit frustrating for some, but that's the order it must be in. So you may have to do some reorganization if you have keys that are on the right side of your data set to begin with. And now I'm putting in $ around the B and the number 1 and E and the number 21 because I want to lock in that table. I don't want it to move when I drag this formula around. And coming back to clinical data set, oops, yelled at me because I wasn't quite finished. We're going to put in a match formula. So just type in MAT and hit tab. You're going to get match. And here's the trick. We're going to select the variable, in this case student. We're going to then hold the top position, and we're going to now use the variable order to make sure that we get the right position of our variable. And if you do this, then what you're going to do is you're going to enable two things. First, you're not going to be guessing at or testing the position of the variable you want to bring in, because this next at this point we have to identify the column index, the position of the variable we want to bring in. This is just going to match it for us, but also it's going to make sure that we don't make a mistake. And then we'll type in false and hit enter. And now